We're in section 5.1 and we're looking at this implicit differentiation. Problem number 10, it's asking us to find the derivative dy dx, and we have this function, and I have the graph here shown below, and we want to evaluate it at the origin, so right around this area here. And we notice that it looks like the slope of the tangent line would somewhere come in here like this, right? So we have some sort of a positive slope. So let's basically, what we're doing is we're going to find the derivative, and then we're going to plug in the x and the y coordinate for the origin, 0, 0 of course, and we'll see if we can get some sort of a positive value right there. Okay, so let's go ahead and take the derivative, and we notice here that the left side of this equation involves a bit of the chain rule. So we have the derivative of sine, which is cosine of a negative x plus y, as my pen freaks out on me here, times the derivative of the inside, which would be a negative 1 plus dy dx, or we could just write y prime. And of course, the right side's pretty easy. It's just equal to 1. Okay, and now we have to solve for y prime, and of course we have to separate these guys out, so we're going to distribute a negative 1 to cosine, and we get negative cosine of negative x plus y, and then we'll distribute this, and we have y prime cosine of negative x plus y, and still equals 1. And so now we just need to move this part of the equation over to the right hand side. So we're going to do that by adding it. So we'll add it to both sides, and when we do, we'll get y prime cosine of negative x plus y, still on the left, is equal to 1 plus cosine of negative x plus y, and then we'll divide this by this quantity of cosine, negative x plus y, on both sides, and we'll get y prime isolated by itself. So we have y prime is equal to, well, this side over here, notice that we have a single term in the denominator, so we could rewrite this as 1 over cosine of negative x plus y. And then we notice something interesting, that these two terms are exactly the same, so this would just be plus 1. Oops. Where's my pen? Let's try that again. It's going to be just plus 1. And now we can plug in 0, 0 for x and y. And luckily we only have one x and one y term here. So let me see if I can get some more space here. There we are. So we have y prime is equal to 1 over cosine of 0 plus 0 plus 1. Well, you add the 0 plus 0, and of course that just equals the cosine of 0, and the cosine of 0 is equal to 1. So we have the fraction 1 over 1 plus our 1, which equals 2. So that tells me that y prime is equal to 2 when I evaluate it at the origin, at 0, 0. And then we kind of looked at that a little bit earlier, and we saw that indeed it is a positive slope right there at the origin. Okay, hopefully this helps, and it's sometimes helpful to get on the internet and find a graphing utility that'll do implicit plots so that you can verify your solution. Make sure that it's feasible.